In this problem we will study a relationship between circuit input excitation, in our case it is current source, and circuit output, in our case it is current. This relationship is linear. A current or voltage is a linear function of excitation. If so, then for the assumed ratio of our circuit response current, which is K, the desired necessary ratio of input should be as well K. So, as we want our current to be 4 times greater than the nominal one, then also current source should be 4 times greater than the nominal value. The increment then is 3J, which is 12 amp. Now, let me consider same circuit, but the problem here is to find a power which is dissipated by a resistor. What is the relationship between an input current source and output a resistor, power dissipated on a resistor? This relationship is non-linear one. At the left we have the same relationship as before. This is a relationship between current that flows through a resistor and excitation, a current source. Power which is dissipated by a resistor is proportional to square of this current. Then, if so, we can see that actually power is proportional to the square of excitation, of input signal. Power is nonlinear function of excitation. Current, voltage is linear function of excitation. So if a ratio of power is K, then necessary ratio of input signal is square of K. In opposite direction, if ratio of input signal is K prime, then ratio of output signal, which is power, which is K prime square. In our case, K, the ratio of power to nominal power, is 4, which means that a ratio of input signal of our current excitation should be square root of 4, which is 2, and this gives an increment of 4 amp. Let me continue with the same exemplary problem. The only difference is that now our output is power supplied by a source. Power supplied by a source, it is a product of this source, current source, value multiplied by a voltage across this source. This voltage is a linear function of this current source. If so, we may take this into account here, and we obtain that the power which is supplied by a source, a current source, is proportional to square of its value. Power is nonlinear function if ratio of power in non-nominal condition to power in nominal condition is K, in our case 4, then a ratio of current source value is square root of K of 4, which is 2, which gives an increment of 4 amp. For this increment we obtain power supplied by this source 4 times greater than the nominal one.